In this video, we're going to go over a couple more examples working with planes that are a little bit more involved. For our first example, we are going to find the equation of a plane that passes through the point P equals 1, 2, 3, and is parallel to the plane negative x plus 3y plus 2z is equal to 4. Okay, so as always, we start with the equation that we're going for, a times x minus x naught plus b times y minus y naught plus c times z minus z naught, and that's going to be equal to 0. And the a, b, and the c come from a vector that is perpendicular or orthogonal to the plane that we're working with. And x naught, y naught, and z naught come from a known point on the plane. Okay, so we're given a point that we want to be on the plane. So this piece right here is actually already taken care of. But what we really need to find is going to be that normal vector n. And somehow this normal vector n has to be based off of the information here that we've been given about it being parallel to another plane. Since it is parallel to that plane, we know that it has to share a normal vector with this plane. So why would that be? If we consider like maybe a side view of our two planes, suppose this is the one that we want, and then maybe this is the one that we know about, and we know we can find from the equation of the plane that we already have information about, we know this normal vector right here, okay? So it's normal to the original plane that we have, but how does it relate to the plane that we want? Well, because these two planes are parallel, this particular vector has to be perpendicular to our plane as well, which means that we can actually, even though, maybe it starts down here, we can think about it as it's the same vector, and we can still just take that and apply it to our plane. So the normal vector of this plane, though, we know that to be the coefficients off of each of our variables for the equation of this plane here. So that's going to be negative 1, 3, 2. And then we already know that our point is 1, 2, 3. And now we have the two pieces of information we need to be able to fill in this equation. So the plane that we want is given by negative 1 times x minus 1 plus 3 times y minus 2 plus 2 times z minus 3. All of that is equal to 0. Or if we want to reformat it, we can take it as negative x plus 3y plus 2z is equal to 11, which is obtained by just distributing each one of these coefficients, adding up all of the constant terms, and moving them to the right. So that's pretty much all there is to this example when we're given a particular point on our plane and then a plane that we want our plane to be parallel to. So for our next example, we want it to contain the point P equal to negative 1, 0, 2. And we want it to have the line for our next example, we want to find the equation for the plane that contains the point P equals negative 1, 0, 2, and the line R of t is equal to negative 1, 0, 1 plus t times negative 1, negative 1, negative 1. Okay, So once again, we start with the desired equation, a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0. And we're looking for a normal vector, ABC, and a known point on our plane, which I guess is already given to us, x naught, y naught, and z naught. Okay, so like I said, we're already given a point P, but we really need to know about this normal vector here. So let's draw a picture and see what we have that we can use to get the information about the normal vector. So let's suppose that this is our plane. And on this plane, we know a point P. And we know about a line that lies on this plane that, say, it passes through that point. I'm going to call it Q. And it points in the direction of the vector, call this guy V, like so. So if we want, we know this vector right here. If we can create one more vector that we know lays in this plane, then we're able to take the cross product of those two vectors to get something that is perpendicular to this surface. And so to be able to do that, I'm going to take this vector right here, QP, and then take the cross product of QP and V in order to get the normal vector that we're looking for. So our plane contains V and QP, our vector, and we can use these to get in. Like so. So in this particular case, QP is equal to 0, 0, 1. So V cross QP, put those all into our determinant bars like so. V was equal to -1, -1, -1, and then 0, 0, 1 here. And we are going to get, for our cross product here, will be -1, -1, 0. This right here is going to be our normal vector. So we take this along with the point P equals, parentheses, -1, 0, 2. And our plane is going to be given by -1 times x minus -1 plus 1, -1 times y minus 0 plus 0 times z minus 2. That's all equal to 0. So if we simplify this down a little bit, we're going to get x plus -x minus 1 minus y is all equal to 0. Or if we want to rearrange this a little bit, we get -x minus y is equal to -1. So just to kind of recap a little bit, what we did was we already knew the point that had to be located on the plane that gets plugged into x naught, y naught, and z naught. So we had to find this normal vector here. And in order to be able to do that, we took advantage of the fact that this vector v, -1, -1, lies along our plane like so. And then we're able to find our second vector, QP, on the plane using the known point from the line, take the cross product of the two to get our normal vector, and then plug all those values in. So that's pretty much it for examples for planes. I'll see you next time.